Okay, so in this lesson we're going to be talking about functions. Chances are you've heard the word function before, but you may not be too familiar about what it is. So, make sure my pen's all right here. Yep, and we're good to go. So what is a function? Well, the best way to think about function is matching. If I tell you to graph the function of a line, you know you have to have points, x values and y values. Those x values represent inputs. Those y values represent outputs. Um, we're going to be talking about domain and range later on, but now we need to think about basically matching those x values to y values. Best scenario to think about all this is people wearing hats. So if we think about the situation in situation A, the scenario, there's three hats and three people. Each person is wearing one hat. So you can see that each hat is matched to each person. Is this possible or is it not possible? Hopefully we can, see this is possible. Makes sense, right? There are three hats and three people. Each person could be wearing one hat. That's fine. What about this scenario? Scenario B, where we have three hats again and three people, but this time we have one person wearing one hat, one person wearing no hats at all, and one person wearing two hats. Is it possible or is it not possible? Well, although it may be ridiculous and silly, it is still possible. Could this person not be wearing a hat? Yeah. Could this person be wearing two hats? Sure. Would you necessarily want to be seen out in public with them? No, but it is possible. And finally, we have scenario C, where this time there are two hats and three people. So this person's wearing one hat, and this hat is being shared between these two people. Is it possible that these two people could be wearing this one hat? No, it's not possible. You can't have two people wear one hat. Um, and there's always somebody who tries to think outside the box, where if you lay it evenly on the two people's heads. Um, but just think conceptually, can the hat fit snugly around two people's heads at the same time? No, it can't. And so this is what we want to think about with functions and points. I'm going to skip this for just a second. And here we have these two, right? So one of these is a function and one of them is not. And so we can see we have points making up these two graphs. We have x values and y values. So try and think right now about which one would be a function and which one would not be a function. And so here are characteristics of functions that will help us to understand this. So I have these two subsets, A and B, over here. And so we're going to say that each element of A must be matched with an element of B. That is a function. So I have some elements in A, some elements in B, and so this is one possibility, right? Each element of A must be matched with each element of B. This is what we had in the first scenario, where we had each hat matches each person. Now we could have the situation where this point here goes to 2 points in B. That's also fine, because this element in A is matched with an element in B. It's just an element. It doesn't say a separate element of B. This value in A can share two values in B, much like this scenario where we had this one person sharing these two hats. Some elements of B may not be matched with any element of A. So there we go. This element in B does not have a match in A. Again, just like the second scenario, this guy here does not have a hat. That's fine. It's still possible, right? Not everybody needs to wear a hat. Not every point in B needs to be matched with something in A. Now, two or more elements of A may be matched with the same element of B. So I kind of did this a little bit backwards here, but that's fine. So like this. An element of A cannot be matched with two elements of B. So sorry, I did kind of mix that up right there. What that means is this. I cannot go from one value in A to two values in B. So I can't go from one hat to two people. That doesn't make sense. It's not possible. So this over here, this would not be a function. This is not a function, and this is a function. So, thinking about this, the conceptual, the abstract nature of this confuses a lot of people lots of the time. So if we ignore that confusion, let's just think about some hands-on examples here. So here we go. Which of these t-tables represents a function, w, x, y, and z? They give us points. Well, with this first one, w, we can see we have two x values going to the same, two of the same x value going to different y values. Is that possible? No, that's not possible. That's not a function. That, again, is like two of the same people getting the same hat. Sorry, two different people getting the same hat. It does not work. We can't do it. Now here, again, in x, we have, again, the same x value giving us two different y values. It's the same thing as w, can't happen. Now notice, though, over here in y, we have two different x values going to the same y value. That is possible. Yes, that can be a function. And same with z. We can see in z that we have two different x values given the same y value. That's fine. But these two zeros here, we can see these are two of the same x value giving two different y values. So that can't be a function. So only y can be a function. Now, you may be really confused right now, but think back to this picture I showed you a couple minutes ago. This represents a function and not a function. You may have heard about the vertical line test before. Look at here. I have this y value here. I have these 2 points. When x is 1, y is 1. When x is -1, y is also 1. That's fine. We can have two different x values giving us the same y value. That's fine. We can have two different hats being worn by the same person. What's not fine is when we have one x value, which gives us two different y values. So here, I can't have one hat being worn by two people. I can't have one x value giving me two y values. And so this is what we sometimes refer to as the vertical line test. Because if I draw a vertical line, it should only cut through the graph once. If it cuts through more than once, it is not a function, because that means that for one x value, there's more than one y value, which can't be possible. Over here, though, if I draw this vertical line anywhere, yeah, look at that. That's a function. There's going to be no point on this graph where it cuts through the parabola twice. So this is a function, and this is not. Um, and so we can solve for this as well, so algebraically. So remember, the best way to look at a function is we isolate the y. Um, if we solve for y, we get y is equal to 1 minus x squared. For any x value here, think of any number of x, plug it in. How many y's are you getting? If you're only getting one y, that's fine, right? Because here, no matter which x value I plug in, I should only get one y. Now over here, though, if I solve this, I get y squared is equal to x plus 1. I have to take the square root. So I get y is equal to the square root of x plus 1. Now when I take the square root of something, don't forget I need to put a plus or minus, right? Like, what's the square root of 9? It's plus or minus 3, because 3 times 3 is 9, and negative 3 times negative 3 is also 9. So here, think of any x value you want. Like, let's say x is equal to 13. Sorry, 15. So if x is equal to 13, then I get y is equal to plus or minus the square root, I said 13 again, 15. If x is 15, I get y is equal to plus or minus the square root of 15 plus 1, which is 16. Well, the square root of 16 with a plus or minus, that's 4, and that's negative 4. That gives me two y values. So when I have one y value, yes, it's a function. If I get any more than one y value, no, it's not a function. And again, if I were to graph that, I would see I have this, if I draw a vertical line, I have it going through the function twice. And really, we can see this anytime. So here, the x is squared, but the y is not. So yeah, that's fine. That's a function. But here, this y is squared. Now, even though this x is squared, I'm going to have to take the square root to solve for a single y value, which means no, it's not a function. And then we can evaluate these functions much like piecewise functions. Evaluating a function just means we're plugging in the value. So here, for this first one, g of x, that's just y. This means it's some function of x. This function is called g. So g of x is equal to x minus 5. Find g of negative 2. Notice we replaced the x with a negative 2. So I'm going to replace the x with a negative 2. So I get negative 2 minus 5. What is that? That's 7. So that means that g of negative 2, is negative 7. Here, just realizing this is a typo, which I should probably fix. Won't let me fix this. Because it's grouped. F of n, right. So here we have f of n is equal to n minus 1. Find f of n. What was the original question here? This is f of negative 8. Why did I change this? Oh, I did want f of y. I'm sorry. That was silly of me. So here, and you can see, it even confused me. We have this function f of n is equal to n minus 1. I replace the n with a y, and that's all I'm going to do here. So f of y is equal to y minus 1. That's it. Done. I replace the n with a y, and that's perfectly fine. That happens sometimes. Don't always think you're going to plug in a value and get one simple number. Sometimes we get a function, and this is going to be important to understand later on. So make sure you don't do what I do and think it was a typo. Over here we have g of negative 5. So here we have g of a is equal to a squared plus 2a. So g of negative 5, we replace the a with a negative 5, so we get negative 5 squared plus 2 times negative 5. So this gives us 25 minus 10. So g of negative 5 is equal to a positive 15. Grand. Over here, f of x is equal to x cubed plus 4x squared. And we replace the x with a 1. So f of 1 is equal to 1 cubed plus 4 times 1 squared. This gives me 1 plus 4. So f of 1 is equal to 5. And then, of course, we could have some fractions here. So the difficult part here should not be plugging in, but for many people it is dealing with the fractions. So again, I have h of a is equal to this function. So I'm going to plug in, instead of a, I'm going to replace that with negative 19 over 10. So I'm going to get negative 2 plus 4 thirds times negative 19 tenths. Now when I'm multiplying here, first thing I want to look at is any common factors. 3 and 19 are relatively prime. 4 and 10 does have a common factor, so I can reduce this by pulling out a factor of 2. I get 2 and 5. So, changing my pen back to blue, I'm going to get negative 2 minus, this is 2 times negative 19, which is 38, over 3 times 5, which is 15. Because I'm dealing with fractions, I need a common denominator. So this is going to be negative 30 over 15 minus 38 over 15 minus and a minus. So h of negative 19 tenths. Negative 30 minus 38 is going to be negative 68 over 15. And over here, x I replace with negative 4 sevenths. So g of negative 4 sevenths is equal to 3 fourths times negative 4 sevenths plus 2 fifths. You can see these 4's are going to slice right off. So I'm going to get negative 3 sevenths plus 2 fifths. Common denominator is what's needed here. So I'm going to say that's going to be 35. So to get from 7 to 35, I multiply by 5. So 3 times 5 is 15. And then plus, to get from 5 to 35, I multiply by 7. So that's 14. So negative 15 plus positive 14 is going to be negative 1. So g of negative 4 sevenths is equal to negative 1 35th. And so that's it with functions and plugging in values, evaluating functions. We do have piecewise functions. Some more problems here. These piecewise functions, it's the same idea, except you plug in based off this domain. So here with these piecewise functions, you can see that f of x is not just 5x minus 1, and it's not just x minus 9. It's 5x minus 1 when x is less than negative 2, and it's x minus 9 when x is greater than or equal to negative 2. So if I look here, f of negative 4. Negative 4 is less than negative 2, so I'm going to plug it into this top equation. So I get, put my work down here, 13. I'm going to get 5 times negative 4 minus 1. This is going to be, so f of negative 4. This is negative 20 minus 1 is negative 21. 14, f of negative 2. Negative 2 is equal to negative 2, so I use this bottom equation. So f of negative 2 is equal to negative 2 minus 9, which is equal to negative 11. 15, f of 0. 0 is greater than negative 2. So I plug it into the bottom equation. So f of 0 is equal to 0 minus 9, which is negative 9. And finally, 16 is definitely greater than negative 2. So f of 5 is equal to 5 minus 9. F of 5 is equal to negative 4. That's that top equation there. And then this bottom one, same deal. 1/2 x minus 10 when x is less than or equal to 6. And it's going to be negative x minus 1 when x is greater than 6. So h of 1 is less than 6. So I'm going to plug that into this top equation. So h of 1 is equal to 1/2 times 1 minus 10. That's 1/2 minus 20 halves. So h of 1 is equal to 19 halves. Again, I used common denominators there. Did that in my head. So if you are confused with that, try working it out and see if you can get to the same answer I did. All right, so h of negative 10. Here, I'm going to plug this into the top equation. So h of negative 10 is equal to 1/2 times negative 10 minus 10. Half of negative 10 is negative 5. So I get negative 5 minus 10, which is negative 15. Number 19 gives me h of 6. This is less than or equal to 6 because it is equal to 6. So I'm going to use the top equation again. So h of 6 is equal to 1/2 of 6 minus 10. 1/2 of 6 is 3. 3 minus 10 is 7. That means that h of 6 is equal to 7. At 20, h of 0, it looks like 0 is less than or equal to 6 again. Wow, okay, so all of these were top equation. That's fine. 0, so I get h of 0 is equal to 1/2 of 0 minus 10. And that's 0 minus 10, which is negative 10. That's piecewise functions. So with piecewise functions, it's just like before with evaluating functions. You replace the variable with the number, the value. Except in piecewise functions, you just have to determine which function you're going to plug the value into, which is not that big of a deal. And so here we have some more extra practice here, and then that's it. So why don't I go through these? So here, f of 7. 7 is greater than 4. So we're going to plug that into the top equation here. So 3 times 7 minus 5. It's 21 minus 5. So f of 7 is going to be 21 minus 5, which is 16. 4 is equal to 4. So we're going to plug this into the bottom equation. So that's 4 squared. So f of 4 is equal to 16. And then negative 3 also in the bottom equation because it's less than 4. So this is going to be negative 3 squared. Be very careful here. We're squaring a negative 3. That means the whole negative 3. See how I put this in parentheses? If you don't put this in parentheses, especially if you use a calculator, you will get the wrong answer. Because you will be squaring a 3 and plopping a negative sign in front of it. Whereas this is negative 3 times negative 3, which is positive 9. And then down here, this is a hefty piecewise function. There are 3 different functions. Don't let that intimidate you. I want to find f of 10. So which has to do with x's that are bigger than 10? This bottom equation. So I get 6 minus 2 times 10. So that's 6 minus 20. So f of 10 is equal to negative 14. F of 2, that's right smack dab in the middle here. So it's just 3. Don't let this confuse you. Again, there is no variable. There is nothing to plug into. So it's just 3. That's it. And then here, f of 0, I get negative 2. This is the absolute value. So absolute value of 0 plus 1. Absolute value of 0 plus 1 is just absolute value of 1, which is 1. So I get negative 2 times 1, which is -2. And that's it. So the work that we're going to be doing with functions is relatively simple. It's going to be a lot of this evaluating piecewise functions, and evaluating regular functions. Um, but do understand characteristics of functions, understand what exactly is going on with functions, um, and this concept of the vertical line test, which should look familiar from algebra, because in the future, when we look at different types of functions, we're going to have to recognize whether or not they are functions. So it's okay if you're a little bit confused about this right now. Again, we will look at this more deeply in the future, but for the time being, really just understand piecewise functions and evaluating functions. I think that's most of your homework. So check out those problems I assigned to you, and good luck.